Intermediate Algebra for Statistics, Using Graphs and Tables to Solve Systems, Part 3. Lesson Objectives. State the three types of linear systems of two equations. Find the solution of a system of linear equations from a table. Lesson Objective. The possible number of solutions to a system of equations. One solution, no solution, infinitely many solutions. Let's do an example. Solve the system y equals 1/2 x plus 1, y equals 1/2 x minus 2. Solution. When we graph these two equations, we see that these are what we call parallel lines. And that's lines that do not intersect. So we say the solution is the empty set because there is not an order pair that is on both graphs, or there is not an order pair, an xy, that will make both equations true. Definition. A linear system whose solution set is the empty set is called an inconsistent system. Example 9. Solve the system y equals -2x minus 5 and -4x minus 2y equals 10. Solution. Our first step is to take the second equation and put it into y equals mx plus b form so we can graph it. So I have to solve for y. The first thing I want to do is add 4x to both sides. Now I want to eliminate the -2, so since it's multiplying, I do the opposite and divide. You have to remember that the -2 is dividing the whole expression, so both terms on the right hand side will be divided by -2. So we have y equals -2x minus 5. And if we look closely, the second equation is exactly the same thing as the first equation. So it turns out these equations are the same line. Therefore, there's an infinite number of order pairs for this system. Because they are the same line, whatever point is on the first equation will be a point on the second equation. Definition. A linear system with an infinite number of solutions is called a dependent system. So let's summarize. Three types of linear systems of two equations. One solution systems. The lines intersect at one point. Solution set of the system contains only the order pair that corresponds to that point. Inconsistent systems. The lines are parallel. The solution set of the system is the empty set. There is no solution. Dependent. The lines are identical. The solution set of the system is the set of infinite number of solutions represented by points on the same line. So let's look at this visually. So here we have an example of a system that has one solution, this point here. Here we have an example of an inconsistent system. There are no solutions, the lines are parallel. And then the last visual, this system, the lines are exactly the same. So whatever point works on the first equation will work on the second equation. And hence we have an infinite number of solutions because there's an infinite number of points on the line. Lesson objective. Example 10. Use a table of solutions to solve the system of two equations. So we have y equals 2x minus 3 and y equals -3x plus 7. So instead of graphing, we're going to look at the table for each equation. And we see here are the outputs for these values of x for the first equation, y equals 2x minus 3. And here are the outputs for the same x's for the second equation, y equals negative 3x plus 7. And we see when x is 2, the y values are the same, 1. So that means 2, 1 is a solution to both equations because that point is on both graphs. That point, when x is 2 and y is 1, will make both equations true. So 2, 1 is a solution to the system. Example 11. Using example 7, verify the solution to the system by using the table feature of the graphing calculator. So if you recall, this is the model for women. This is the model for men. So using our graphing calculator, if we put the women in Y1 and the model for the men in Y2, and then we hit second and window, which is table set, we change to where the table will start at 77.76, and this is how much we count by, and let's count by 0.01 instead of 1. And we see at 77.76 y1 and y2 have the same y value, and that is the only place in the table where y1 equals y2. The solution to this system would be when x is 77.76, y will be 85.695. Thanks for watching.